Hi there and welcome to today's class. For today's class, we're looking at the solution to Physics Practical Experiment M6, Horizontally Vibrating Rule. The aim of this experiment is to determine the relationship between the period time capital T and the length capital L of a bifilar suspension of a half-meter rule. So you have your apparatus here and the methods. We'll just jump into the table and try to complete them and answer the questions. Alright, so we have this one here. So this is the results. Time for oscillations. For time for 10 oscillations, you have L when L is 80, 70, 60, 50, 40, 30, 20 cm. You have the first time and second calculations. Alright, so here's your table. Um, if you're given this, obviously your first task you'll be given from your experiment, you'd have to get the value of T1. You have to get this whole column T1 and also T2. Alright, you have to find these two. Now your first you have to when you're so you have to find the value of T1 and T2 in the lab, which you'd conduct your experiment and do. Now, next up, when it comes to finding the mean T, so usually mean T here will be empty, and also the period will also be empty. So let's look at how we can get our mean T. For mean T, note that the mean T is equal to, your formula is T1 plus T2 all divided by 2. So T1 plus T2 over 2 should give you your mean T divided by 2. That's how we get the mean T. So just take some few examples to explain this. So that's equal to, let's take the first one here. For this one here, we'll get our value. We'll get our value by doing this one here. At L equal to 80, T1 is 17.01 plus T2 is 16.90. So 16.90 all divided by, so divide all of this by 2, and if I do this math I would have 16.96. This is how I get this first mean T. Let's try for the second mean T. For the second mean T, I would use this one here, which is 16.44 plus this one here, which is 16.27. I'll divide this here by 2. If I solve this math, I'll have this value here, which is 16.36. Alright, so use this idea to fill up all of them. Alright, that's how you get your mean T, basically. Alright, so use this idea to complete the column for mean T. Next up, let's look at your period T. Let's look at the period. Look at period capital T. The period capital T would be equal to the mean T. So to get the period T, just divide mean T divided by the number of oscillations. If I look at this, it said for 10 oscillations here. Look at this part here. It says 10 oscillations. That means I'll divide it by 10. That's all. So that's equal to, take this one here and divide by 10. It becomes 1.69, sorry, it becomes 16.96 divided by 10, and if I do this would become 1.696. But notice that everything on the table here is in two decimal places. So in two decimal places this becomes 1.70 approximately. That's how I got this value here. Alright, I'll take one of these again and try to explain the next one. So the next one here, I'm having this one here, 16.36. So the period becomes 16.36 divided by number of oscillation, which in this case is 10, and that's equal to 1.636. In two decimal places, this becomes 1.6. So 6 here to this is a plus 1. 3 plus 1 gives you 4. I have 1.64. That's how I got this. So just divide each of this by 10 and approximate correctly. You have this value. All right, that's how it gets the period T. So that's it basically. All right, so we're done with how to fill up the table. Let's look at the data analysis. Let's look at data analysis and try to answer this question. All right, the first one here, okay, moves a bit. Data analysis. The first one here says, assume that T and L are related by the equation T equal to AL to power C, where A and C are constants. Transform the equation by taking log of both sides to obtain log T equal to C log L plus log A. So you're to show that T is equal, they're giving you that T is equal to AL to power C. They said you should transform this into this log function. How do you do that? So first things first, take log of both sides. So I have that log of T, left hand side, is equal to log of everything on the right hand side. That becomes log AL to power C. So we have this. All right, so I have this there. So what's next? So into log everything on the right hand side, AL to power C. So I have this. All right, so what's the next thing there? My next thing is to expand this bracket here, the one on the right hand side. So I'll have something that looks like log of T is equal to, from the laws of logarithm, if I have two terms like this, how do we solve this? It becomes log of the first term, which is A, so log A, plus log of the second term, which is L to power C. So I'll have this. Okay, so what next? From here, I'll have that log T is equal to log A plus, now one of the laws of logarithm says that if you take the log of a number of any term such that the term is raised to a power, as you can see here, now what happens is that the power comes down and it comes like a coefficient here. So the C comes down here, becomes C log L. This is mathematically correct, all right? In mathematics, it's correct. All right, so what next here? From here, I'll now have that log T is equal to, if you look back at this, they said log T is equal to C log L plus log A. But I'm having log A plus C log L. They're the same thing. All I have to do is to rearrange. So I'll just bring this one first. That becomes C log L plus, bring this one next, log A. So with this now, I have answered that question. All right, so that's the solution to that one there. Let's look at the next question there. The next question here says, prepare a table of log T and log L corresponding to the table T and L above. So we have to prepare a table. If you look at this, you have T, capital T, that's your period. You also have capital L, that's your length. So we have this. So we have to prepare a table of log T and log L. So let's get the table ready. All right, so with this now, so this is my prepared table of log T and log L. So all you have to do is just to take the log of each of your period. All right, so take the log of this first one here, 1.70. You have 0.23. Please keep all of them in two decimal places. Take log of the next one there, 1.64. Log 1.64, you have 0.21. Take log of 1.55, you have 0.19. Take log of 1.37, you have 0.14. Take log of 1.23, here you have 0.09. Take log of 1.04, you have here 0.02. Take log of 0.89, you have minus 0.05. So I'm done with this. Let's get for log L. So I'll take log of 80, that's L here. Log 80 gives you 1.90. Log 70, that gives you 1.85. Log 60, that gives you 1.76. Log 50, that gives you 1.70. Log 40, that gives you 1.60. Log 30, that gives you 1.48. And log 20, that gives you 1.30. With this, I have prepared a table for log T and log L. Now, mind you, in your own table, you don't have to show this log. It's not important. Just go straight to writing these answers. Like, so here should be 0.23, 0.21, 0.19. They know how you got it, all right? I'm only writing this one here because I'm explaining so that you understand better, all right? So in your own table, you don't have to start writing log 1.70. It's not important. Just write the final answer. So here should just be 0.23, 0.12. So that's it. So also here should be just 1.90. You don't have to write log 80. They know it's log 80, right? So just write the final answers. That's what I'm saying. All right, so if I'm done with that, what's the next thing? Then number 4 says measure the slope and intercept. Okay, the third one here says plot a graph of log t against log L. So I've plotted my graph. Let's see what it looks like. All right, so this is what my graph looks like. All right, so when you plot a graph, you have this. Take your line of best fit and you have this. So this is what my graph looks like. So back to my, so you can also plot your graph and then see what you get. All right, back to my question. Number 4 says measure the slope and the intercept of the graph. Let's go back to the graph and measure slope and intercept. So as usual, the graph gives me the value of my slope here. So you can see here. So from here, the graph is telling me that the slope is equal to 0.49 approximately in 2 decimal places. All right. Now, since I'm taking slope of log t to log L, I'm having my slope as 0.49. So from here, my slope becomes S is equal to minus 0.49. That's like so my slope here is equal to 0.49. As you can see here, that's my slope. Okay, so slope then the slope is 0.49 from the software I'm using. Intercept C, the intercept will be the intercept on the log t axis. To get that value, I'll have to go down. So go down like this. So see where it cuts the log t axis. That's this point here. So you read out what this point is on your graph. Luckily for me, the software is telling me that my intercept from here is equal to minus 0.69. And of course, so I'm having minus 0.69 as my intercept. So I'll just come here and put my intercept as minus 0.69 as my intercept. 69 approximately in 2 decimal places as my intercept. So with this, I've gotten the slope and the intercept. Let's look at the number 5. So of course, when it comes to, let's do this manually. Okay. So when it comes to doing this manually, okay, you can, let me take this off first. Take this off. So you can calculate your slope. I think I've showed this in my other videos. So you can check out my other classes here. Look for the point where the 3 lines meet. I've explained this before, but let's see. Okay. Okay, so I have somewhere here. In this case, I have somewhere here. Take this point here. So in this point, I have that. Okay, let me show you here. So when it comes to picking your point for slope, look for a point where this one here, this way, you have your vertical line, you have your horizontal. They now have your line running this way, something like this. Right. So you now look for this point like this, where 3 of them meet, something like this. Where 3 of them meet. That's how you take your point for your slope. That's how it's done. All right. Okay, so back to my this. So I could take this first point here, which is this one here. Let's see, can I find another point again? I'm finding another point again. Let's see. Mm, Not really. But I think since this is actually like a keyboard graph. So if you use a proper graph, you should have where the intercept. But let's assume the intercept. Let's assume the intercept here. All right. So what you do is just simple. From here, you mark this off like this. Mark this off like this. Now yours might not be under this. Okay, fine. Let me correct this impression. So yours might not really be under that's below the x-axis. You can choose your own somewhere here too, like this. Then choose your point. But I've done this also in my previous classes, so you can check how I plotted my graph in my previous classes, and then that's it. So from here, you trace this value like this to this side here. Trace this value to my left hand side here. So that becomes, this becomes log, here is log T2. From this point here, trace this value this way, trace it to this left here. This point here, this first point is log T2, 0.7. This second point here is log T1. Trace here down. If I trace this down here, this value here becomes log L2, trace this value here down. This becomes log L1. So my slope will be equal to change in log t all over change in log L, and that will be equal to log t2 minus log t1 all over log L2 minus log L1. So you have something like this. So you just collect the values, right? So take this value here. Now something that looks like 0.7 minus, trace this value here. That's 0.3 all over log L2. Trace this downward to this point here. I have about 2.9 minus, trace this one down here. That's about 2. All right, so you do from here, you just complete the maths there. This is just a demonstration of what it looks like. I already have my value from the software. All right, so let's proceed with this. Going back to my work, so that's how you get your slope and your intercept. Okay, so what's next in here? Number 5 says, hence calculate the constant C and A. Calculate the constant C and A. How do you calculate the constant C and A? What do we do? Let me show you how we calculate the constant C and A. Now, first things first, recall your equation here. Recall this equation. Recall that. Okay, excuse me. So first things first, recall the equation. Recall that we said log t, from the equation we derived, log t is equal to C log L plus log A. Alright, we asked to calculate the constants C and A. How do you calculate the constants? Can we start with which of them first? I think the easiest to calculate here will be A. Why is A the easiest to calculate? Because from this one here, if I look at my equation here, if I look at the equation here, now normally for a straight line equation, we have that y is equal to mx plus c. This stuff matches that, so y is log t, and that's why log t was plotted on the y-axis. C is same thing as m, which is your slope. X is your log L, that's why log L was plotted on the x-axis, and then log A is equal to what there? C. This C here is actually the intercept on the y-axis. That's the value of C. And so if you ask to find the value of calculate the constant C and A, it means that log A would be equal to the intercept on the y-axis, which is what there? C. This one here, intercept C. So log A will be equal to the intercept C. That's the concept. So if this is true, if log A is equal to C, what does it mean? It means that from here, I will have that log A is equal to C. What's C there? We got C as minus 0.69. As you can see here, this one here, minus 0.69. Okay, so what next there? Let's get A. To get A, I'll have to take the anti-log, becomes the anti-log of 0.69. All right, that's how we do this. Take the anti-log. From here, we'll have that A is equal to, the anti-log of 0.69 is about 0.20. So I've gotten the value of A as 0.20. I have calculated A. Now let's calculate C. How do you calculate C? Say calculate the constant C and A. Alright, so let's get the value of C and A. Okay. Now when it comes to getting the value of C and A, calculate the constant C and A. What you do is that you go back to your this equation here, where you have that log T is equal to C log L plus log A. So let's get this done. So we said T or log T is equal to C log L plus log A. So I have this. We have to calculate the value of the constant C and A. What do we do? So I'll simply come here. I'll take this value here. This first value of log T here, which is 0.23. That means when log T here is 0.23, is equal to C. What's the value of log L? Log L here is this value here, this one here, the first one, which is 1.90. That gives you 1.90 plus log A. There's no log A value, so we'll assume it to be an unknown. So it becomes log A. This is my first equation. Take the second values. Look at the second one here. When log T is 0.21, I will have that 0.21, that's log T, is equal to C into log L. So when log T is 0.21, what's log L? Log L is 1.85, so it becomes 1.85 plus log L, we don't know the value. So with this, we are seeing a simultaneous equation. We'll solve them simultaneously. And if I do that, it's just simply subtracting them. So if I subtract both equations, what do I have? Firstly, I have 0.23 minus 0.21, and that will be about 0.02 is equal to, bring down the C, subtract the numbers in brackets, 1.90 minus 1.85, and that will be about 0.05 as your value. So I have 0.05 as a value plus log A minus log A, that gives you 0. So what you're seeing here is mathematically correct. It's C times 1.90. So it's like saying 1.9 times C, that's 1.9 C minus 1.85 times C, that's 1.85 C. So it's just you saying 1.9 C minus 1.85 C, and that will be 0.05 C. It's the same thing, all right? Alright, so if that's so, this will now give you 0.02 is equal to C times this gives you 0.05 C. To get C, I'll divide here by 0.05, divide here by 0.05. So this cancels this. You have that C is equal to 0.02 divided by 0.05. You have 0.4. So the value of C is equal to 0.4. Don't forget, C here means slope, all right? Because my equation is equal to y equal to mx plus c. This other c here is intercept, so don't confuse between the two c's. The c we are calculating here is the slope, all right? So this value now becomes the exact value of the slope, all right? So this now become my exact value for the slope. Again, let's get for A, because we asked to calculate what there? Calculate the constant C and A. I've gotten C. Let me now get A. So how do I get A? I'll put this value of C into any of this equation. Alright, let me use the first equation. From my first equation, I have that 0.23, that's this one here, is equal to C times, from here, C times 1.90, so it's equal to C into 1.90 plus log A. So plus log A, I have this. Alright, if I put in the values, I have 0.23 is equal to, we've just got C as being what there? 0.4. So I have this as 0.4 into 1.9 plus log A. So this now becomes 0.23 is equal to 0.4 times 1.9. That's about 0.76. So this gives me 0.76 plus log A. If I subtract this, move this man to the left hand side, I have 0.23 minus 0.76 is equal to log A. So 0.23 minus 0.76, that gives about minus 0.53. So I have this as minus 0.53 is equal to log of A. So to get A, I will take the anti-log of that number, becomes log inverse or anti-log of minus 0.53. Alright, so I'll punch this with my calculator. If I punch that, the anti-log of minus 0.53 is 0.30. This becomes the exact value of A, 0.30. So alright, so if you have this now, we can now say that hence the value of C. So we have to find the value of A and C. So A, from my calculation, as you can see here, is equal to 0.30. Okay. Okay, so from my calculation, A is equal to, let's look at this value. That's 0.30. That's the value of A. So from my calculation, A is actually equal to 0.30. Also, for my calculation, the constant C, which is the slope, for my calculation, C is 0.4, as you can see here. So I'm having this man here as 0.40 as my calculation. Alright, so the next one says evaluate the standard errors in A. So we know that to get standard error, let's try to see this. So standard error in A. Standard error in A. So that will be equal to error minus exact all over exact, and that's equal to the error would be the one from your slope or from your graph, which we got here as 0 minus as 0.2. So this is the value here. We got this one from our graph sheet as 0.2. So my value should be 0.2. So 0.2 minus the exact, as we calculated, is this one here that we got 0.3 as an answer. So minus 0.3 all over exact, which is 0.3. So all over 0.3. If I do this maths, that will be equal to 0.2 minus 0.3 is minus 0.1 all over 0.3. And if I do this here, this will be equal to minus 0.33. Alright. But we want our error to be a positive number. So what do? We just simply take absolute value. So I'll come here, take absolute value of this, 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 of course, my formula 2, come here, take absolute value of this, come here, take absolute value of this, and finally, I'll come to this one here and take absolute value. The concept of taking absolute value is to ensure that the error is a positive number. That's all, no big deal. So if I take absolute value of this, I will have that this is equal to, the negative goes off, it becomes 0.33 as this. Alright, so if I'm asked to express my answer, it means that the error in A is equal to, have that A will be equal to, so I'm writing this in this top here because of this space is small, so you can write yours there, but let me write it here. That's equal to 0. This will be 0.30 plus or minus 0.33. So that's this for A. Let's now get for C. So the same thing too, standard error in C. I'll just change this to C. So change it to C. I can take up this ones here. Let's get for C. Alright, so let's get standard error in C. That will be equal to error minus exact all over exact. C, the error in C would be the C from, let's say this. So how do you get the error in C? Don't forget, this is the exact of C, right? the error in C, don't forget C represented the slope, right? Because from this equation, you can see that the C here is for my slope. So the error will be the one from the graph, which if you go here, the error here is 0.49. That's from the graph. So the error here is 0.49. That's the C. Then the exact is the C as we calculated as 0.4. So if that's so, it becomes equal to absolute value of error 0.49 minus exact 0.4 all over exact. So all over the exact here is 0.4. All right. Of course, I'm taking absolute value. Take absolute value here. Take absolute value here. This will be equal to, simplifying further, this will be equal to 0.49 minus 0.4. That's about 0.09. So 0.09 all over 0.4. So what do we have here? Taking absolute value here. This will be equal to the absolute value of 0.09 divided by 0.4. About 0.23 approximately. So if I take the absolute value of 0.23, I'll have 0.23. So my value there is 0.23. So for C, I'll have that the error in C is equal to 0.40 plus or minus 0.23. So that's the answer for this. So this is how we get the solution to this. Next up, let's answer the questions there. Question, the first one says, what aspect of the setup is the constant A likely to depend upon? II says, what is the unit of A if the relation is given? What is the unit of A if the relation as given above is valid? III says, guess any practical application of this setup in nature. IV says, should theta be larger or smaller, and why? All right, let's see how. Okay, so the I here. So let's look at the answers to the questions. So the first one there, we asked what aspect of the setup does A depend? The answer is that the constant A depends on the length and the mass of the meter rule. So these are the aspects of the setup that the value of A depends upon. The next one, we asked to find the SI unit of A, assuming that the relation is correct. Now the answer is that the SI unit of A will be in centimeters. All right. This is because A represents the amplitude of oscillation. So that's value of A. So A means the amplitude of what? Oscillation. And if you look at the distance here, for my question, if you look at the distance here, distance was given in centimeters. So that's why A should also be in what? Centimeters and not meters. Usually the amplitude should be in meters. But since we are taking a measurement in centimeters, it means that my unit should be centimeter. All right, the third one says some practical applications of the setup in nature. The first one is the mechanical system analysis. So the setup can be used for mechanical system analysis for analyzing and designing various mechanical systems. Example, the suspension systems in vehicle. Also, the setup can be used for structural health monitoring of the oscillation of structures to provide valuable information about their structural integrity. Now, this one is for civil engineers. Also, the setup can be used for seismology to study the vibration produced by earthquake. So when we say seismology, we're talking about the study of earthquakes and the likes, right? So it can also be used to study the vibrations produced by earthquakes. All right. The next one, therefore, says, should the angle theta be smaller or bigger, and what's your reason? The answer is that theta, the angle there, so theta should be smaller. Can you write it properly? All right. So the answer here is that theta should be smaller because a smaller angle ensures that the experimental setup remains consistent with theoretical assumptions. hence enabling more precise and accurate measurements, leading to more reliable results. So that's why theta should be made smaller and not bigger. All right, so we're asked to make a conclusion. All right, so from the conclusion, what can we say? So in conclusion, we can see that from the experiment, all right, from the experiment, it can be found that the relationship between the period time t and the length L of a bifilar suspension of a half-meter rule is given by the equation. In this case, the equation should be log t is equal to c log L plus log A. So this is the equation here. If we want to impute values, we can say better still, the equation is most likely log t as equal to the value of c as we got was 0.4 into log L. So into log L plus the log A we got was 0.3. So 0.3 as the exact value of log A. Right, so this was like the equation we get. All right, so this is the solution to this experiment. So if you enjoyed this video, please make sure you like the video. Okay, like the video. um, Please leave a comment, tell us if you enjoyed the video, and also suggest other experiments you'd love to see. And of course, why not share this video to your friends so that they can also benefit from these classes. All right, so this is how you can encourage me to keep producing this kind of videos. Make sure you like the video, leave a comment, share the video to your friends, and finally, don't forget, please subscribe to this channel and turn on the bell icon so that you get notified whenever I upload a new video. Thank you very much and see you in our next class.